This is another set of just multiply and combine like terms. So if you're multiplying and combining like terms, in order for it to work, you have to have same nth roots. You simplify the radicals, and you add or you subtract, and so on. You also can use foiling, just like we've done in the past. We'll FOIL with some radicals here and there. You'll rationalize your denominators, which you have before, by multiplying by conjugates, which you've done before, so it's not anything, this really isn't anything new. This whole thing is a lot of review, so we should go fly kind of through it. So, like I was saying, it looks really, really weird for nothing more than just combining like terms. Let me just show you an example right off the bat. Yeah.
Sometimes it tells you that you're wrong. It's like rewrite the expression so that there are no radicals in the denominator, but it's like there aren't any radicals in the denominator, but that's not what I messed up.
Well, we'll worry about it now. So in this case here, if I have 3 root 5x minus 2 root 5x, what do I get?
5x. Root 5x.
Root 5x. Because I'm just combining like terms. Okay. And I go to the next problem. Okay. 6x squared root 7 plus 4x root 5. And I combine that. No.
So that's its simplest form.
Yes.
You have 2 different degrees and 2 different radicals.
Okay. Let's just combine my terms, guys. Can't do it. The answer here is no. No. Exactly. Just like I've said before, this unit, these first 3 units, 3 or 4 units, was basically the first 2 sections of the old book. Thought maybe taking a breather would be okay.
You can combine these units.
What's your answer?
No.
No. Okay. Why don't you like move up if you're gonna do that, so that way I
I
don't.
should have plugged it in that one.
You can just hurdle it. What?
Because I'm gonna die.
Just hurdle it.
Okay, I'm glad that wasn't your computer.
Emma, I'm surprised you didn't fall. Or
Why don't
trip
you
on it.
just put the Chromebook in the back? Because you don't need it right now.
There we go.
Just gotta get ahead on math.
You won't trip over that.
You're just walking upstairs.
I tripped
What do I do here? In this case here, you can create common denominators. You can create common roots. So you simplify your radicals. The square root of 12 can be rewritten as what? Square root of 25 can be rewritten as? Sorry, square root of 75 can be rewritten as? 5 root 3. So what's 2 plus 5 minus 1?
6.
The answer is?
6 root 3.
Simon says, ding. Circle gets a square. I mixed up my game shows there, I believe.
Circle gets a square.
Price is right.
That was called Tic-Tac-Toe. It was not a very good show.
Oh wait, how did you get that? You did 7 minus 1
Yes. Or I did 5 minus 1 plus 2.
No.
Or I did 2 minus 1 plus 5. Or negative 1 plus 5 plus 2. There's a plethora of things we could have done there. It's always fun to use the word plethora. Oh no, I'm afraid. Are you trying to mock me? She hates me.
Oh no, but they do. Can get a knife with the movie. You did that, you did that.
So I have. Again, all we're doing here, guys, is we're going to FOIL out. Good old Billy binomial and work our ways through. We FOIL out and we simplify. 20 plus 16 root 2 plus 10 root 2 plus 2 root 2 times 4 root 2. We'll come back to simplifying that here in a second.
It wouldn't be 8 root 4.
Otherwise known as
2.
16. Very good. So 20 plus, well, 16 root 2 and 10 root 2 is,
26 root 2.
this becomes 8 root 4 when you multiply it out. 8 root 4 is 8 times 2, otherwise known as
16.
16. So your final answer becomes 36 plus 26 root 2. This is the proper format to write it out. You put numbers first, and then you go into ones with radicals. That's it. It's just foiling. Okay? It's just foiling. Excuse me. What's wrong? You're staring at it cross-eyed. Yes.
Plus 16.
Multiply those two, you get 8. Root 2 times root 2 is 2. Square root of junk times square root of junk is junk. So I get 8 times 2, I get 16. And then the last one. Oh, no. Do we like radicals in the denominator?
Yes.
No. They're evil and scary and frightening and cold,
Evil.
like my heart. So we've done this problem before, but you've done this problem with an imaginary number. You did this problem by multiplying by what we call a conjugate. You created a difference of squares within the denominator. By doing so, you eliminated the I value. By doing the same trick, you will eliminate roots. So the conjugate of root 5 minus root 2 would be root 5 plus root 2. Está en fuego.
It's on fire.
Because what's root 5 plus 2 divided by root 5 plus 2?
1.
1. It just looks weird.
Wait, what did we do? Root 5 minus root 2.
What did I do that for? I just multiply by a conjugate because what I'm doing is I'm creating a difference of squares, which is going to eliminate all the roots. Because what's root 5 times root 5? Would 5. Root 5 times root 2 minus root 5 times root 2 goes away. And then you have minus 4.
1.
I'm glad you were paying attention. That was a trick.
3.
And I caught it.
Good job.
Thank you.
See if you can catch this. Yes! You're 2 for 2. All right, so what happened here is we FOIL it out. We get root 5 times root 5 minus root 5 times root 2 plus root 5 times root 2 minus root 2 times root 2. The middle terms drop out, okay?
Wait, where did you get that from?
If I FOILed all of this out,
Wait, oh, but where'd you get the card?
this goes away. What's the square root of junk times the square root of junk? Junk. So what's the junk here?
Oh, you were just showing what you did to get that. I was like,
Square root of 2 times the square root of 2 is 2.
Becomes 3 on the bottom.
don't erase it.
Wait, keep going, keep those solving the problem.
Very good. Whatever. So the middle term goes away. So now the top you just distribute, and you get 3 root 10 plus 3 times 2, which is? Okay. So now I have a fraction that I need to rewrite.
Oh.
I'm at a fraction now that I need to rewrite. So when I rewrite this one, I'm going to get 6 plus 3 root 10 over, 3 root 10 all over 3. Which means, what can I do?
You could do one, I mean,
3 root 2 times root 2
you can
is
simplify
3
it,
times 2.
you can simplify it to 2 plus 3 root 10.
Close. What's the GCF of the numerator? 3.
Plus root 10.
So if I take out a 3, I get 2 plus root 10.
You divide that by the 3 on the bottom.
That's how you drop it out.
And
You have to simplify it over both parts.
So are we supposed to do that?
Yes.
How did you get
Why,
the
why
2?
can't you just cross out the 6 and the 3?
2 and the 20.
Because then you can't simplify just over addition. You can only simplify over multiplication.
Oh, wait. Where'd you get the 2 and the 20?
Yeah.
That's a 10.
But where'd you get?
I took a GCF here. What do they have in common? A 3. I factor out a 3. I'm left with a 2 and a 1.
Oh, I thought you multiplied the 3 to get rid of the bottom.
Wait, so then where'd the 3 go?
I divided it out.
You took the
I'm not
greatest
fine.
common factor
Okay.
of 6 plus
Once
3.
again, we are at this. 6 plus 3 root 10 all over 3.
Okay.
Now, I can do this one of two ways. First way, numerator has a GCF. They both have a 3 in common. If I factor out the GCF, I get 2 plus root 10 over 3. What's 3 divided by 3?
1.
1.
Wait, what do you do if they don't have?
Then you leave it.
So, like,
If this was over 13, you're done.
so like, what if the 3 on the top was a 4? Could
Yeah.
you simplify the 6 then?
No.
Or no?
No.
Okay. You just
They have to all be divisible.
Okay.
all-
And it has to be divisible by the bottom thingy too.
Yeah, you have to have, or a common factor. Okay? If they were, let's say it was 6, 4, and a 2. You can divide them all by 2.
But what if it was the 3, but then it's like plus 2?
Over here,
Yeah.
you can't do it. Then you just leave
So
it.
you just leave it?
Yeah. The other way I could have done that is that this, by being all over 3, means it has they have already a built-in common denominator. That's another way of rewriting it. 2 plus root 10. That's another way you could do it. Normally you'll see it if all 3 parts have a GCF, that's when you simplify it out from there. That's what it works. That's about as scary as this stuff gets, really. I guess it could start with 6-4.
No.
We could be on math Excel.
Yeah.
I mean, I think it's on there.
We just do the homework for 6-3 right now.
Yeah, but I want to get.
It takes them so long.
I'm trying to think here.
Heads or tails on the calculator? Can you? Yeah.
Flip a coin on the
Flip a coin.
Oh yeah, that's right.
Flip a coin on the calculator.
Let me look at what I have in here already for 6-4 because it's just the rules of it.
Are we doing paper problems?
No, it's already in the system. So in 6-4, it's using our nth root rules. And believe it or not, we've actually covered most of this. This just kind of combines everything into one spot. For example, if you have any nth root of x, I can rewrite that as a fractional exponent. We discussed this the other day. If I take the square root of a number, it's the same thing as taking that number to the half power. So if I say that I have an nth root, what's going to be my exponent of x?
1
X to the 1 over n. And it works going both ways. Okay. Now, also it comes into play here where when you're working with fractional exponents, you can still follow all the same rules of same base, different exponent. What do you do to your exponents? You add them. Same base. Raised to an exponent, what do you do? Power to power, what do you do? multiply. What is an exponent to a negative 1? Anything to a negative? I should write that as a negative n. A to the negative n. Is it happy where it's at? No. So it becomes 1 over a to the n. What if it's in the numerator or in the denominator? You move it up. What do you do when you divide? You do, but how did I always put it? Play war, yeah, play war. Play war. To figure out who wins.
Everything so
Play war and then subtract to figure out where it's going to wind up going. We've been doing all of these all along, but the only thing that'll change is that they'll throw a fraction exponent in there, which means you have to multiply fractions or add fractions. Okay. Now, what is anything to a 0 power? 1. Okay. Now, if I'm not mistaken, you double check here. All right, so that just loaded. Let's see what this looks like. Is it live? Did you guys refresh? Did 6-4 come up? Yes, it should have. All right. I'm just curious what it looks like. I kind of breezed through it. Come on, computer. Oh, it's rewrite. Okay. Nobody likes you. Good job. I think you're a very nice person, actually. We'll just kind of harass you because it's fun. What if I want to rewrite that as an nth root? What if I want to rewrite that from a fractional exponent to an nth root? What's the denominator? N. So that's your nth root. Oh, it is. Because it's the nth root raised to a power. Okay. You should be able to figure out some of these. They might be a little tricky here and there, but we'll go from that tomorrow. That way, what's nice is that you guys get an idea of how to try to start a couple of these things out. And then tomorrow, since we're going to quiz on this stuff on Friday, that way tomorrow during class, I actually have already made it's an actual piece of paper, thank you, you're welcome, of some review stuff of all of the exponent rules of everything that we've done. And it just kind of pushes it all back together. So that way we can go over some of the problems from the 6-4 together, and then we can work on stuff in class and just kind of review it all right away. Because you're right, this does kind of tend to really go slowly through it. And this way it'll buffer us in a good extra 25 minutes to now just review. Okay? Does that sound like a deal? Okay.